Action.
All right, so today we're going to start with determinants. I don't know if we'll necessarily get as far as the last class because obviously we had the fire drill, so we might not get as far into Kramer's rule as I want, but that's okay because we're going to pick that up then tomorrow. And then so tomorrow would be then Kramer's rule type of wrap-up day with determinants and all that fun stuff. Wednesday, there is a formative on Wednesday. Plan on the formative. It's the formative that you were supposed to take last week, but weren't ready for it because we didn't have class on Tuesday to take it. So that formative will be this week then. Thursday, then, we are going to wrap up solving systems of equations with our fifth method of solving, and that's going to be matrices. But we got to go through determinants here first in order to get to that. Then Friday we'll wrap up that section. Next week, Monday, we will be reviewing all of Chapter 3. And then next week, Tuesday, the 21st, we will be taking a Chapter 3 test. Okay. Yeah, that's all I got. Okay. So, a determinant is something that we can find from a matrix. Okay. A determinant boils an entire matrix down to one value. Okay? No matter how big your matrix is, the determinant is going to be one single value, one single number. Okay? They can be positive, they can be negative. Okay? This value then allows us to use matrices to solve systems of equations, which we'll get to later on today, hopefully for sure tomorrow. Okay? So, a determinant has one special condition. I had to think of the word that I wanted to use there. And that is that the matrix, if it has a determinant, the matrix has to be a square matrix. Okay? If it is not a square matrix, it does not have a determinant. Okay? You cannot find the value of a determinant on a non-square matrix. Okay? What does it mean to be a square matrix? Well, a square matrix is where your rows are, the number of rows is equal to the number of columns. So a 1 by 1, a 2 by 2, a 3 by 3, an 18 by 18. All of those are square matrices. The number of rows equals the number of columns. Okay. Now, we are going to have, or we're going to learn two ways of finding determinants today. Okay. We're going to learn it by hand, and we're going to learn it using the calculator. Okay? So I'm going to pause the recording right now. If you want to go grab yourself a graphing calculator out of the box, not over here, these are stats, ours are over there. Okay? If you want to go grab yourself one out of the box, you will need one. Okay? So, 2 by 2 matrices are relatively, I don't want to say easy, but you will be faster at finding the value of a 2 by 2 determinant by hand than you will by calculator. Okay? Just so you know. It's quicker to do the value of a 2 by 2 determinant by hand than on the calculator because there's so few steps involved. Okay? All right? So, step number 1, by the way, the value, or if we're finding a determinant, we have straight sides. Okay? straight sides on our matrix. Okay? If we have brackets, that means we're talking about it as a matrix. If we straighten out those sides, then we're asking you to find the value of the determinant. Okay? So, to find the value, we shorten up determinant to DET. Okay? So if I want to find the value of the determinant of matrix A, okay, by hand, we are going to actually let me put that in the big letters. We are going to crisscross. Makes you wanna jump. Okay? For those of you that don't know what crisscrossing is, crisscross makes you wanna jump. Okay? Which alright? So, what I mean by crisscross makes you wanna jump. Okay? So, Chris is going this way. So we take these two numbers and we multiply them. Okay? So 6 times negative 4. Which is negative 24. Okay? Then we're going to subtract our cross. And I multiply those two numbers. Okay? So that's going to be 1 times negative 2. Okay? So cross goes that way. Okay? So negative 24 minus negative 2 is? No. Negative 22. Okay? Determinants are always crisscross. Makes you want to jump. Okay? Oh, and that's the favorite part of the song. Wiggity, 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 whack. Okay? So, first find it by hand. We'll go back to the start. Who knew that this section had its own theme song? I don't want to know about it. Because I'm a crisscross guy, man. I know, I knew that because I was, when I typed in Google crisscross, the Chris Brown one came up too, but I wanted this one. Okay? There it is. Wiggity, 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 whack. I get 15. Yeah? Okay? Now, on the Inspire calculators, we can also find the value of the determinant. What you're going to do is you are going to, actually here, I'm going to write this down so I don't have to flip-flop back. So that's going to be 3, -2, 6, and 1. This is riveting internet listening right now as I'm writing these down on the board and they can't see anything. Okay? So, on the Inspire, what you do is, okay, first you type in DET. Okay? It's not a button. No. You just literally type it in. DET. Okay? And then you're going to open up yourself a set of parentheses. Okay? Now, here is where you've got to do some finding of things. Okay? This button right here, okay, this red button right there that I have highlighted in red there is the shortcut button. Okay? So it takes you to all of these different things. You've got radicals, you've got exponentials and logs, you've got piecewise functions, degrees, minutes, seconds, and then you've got this in this middle part right here. You've got this whole, I don't think I can draw in here now, can I? Nope, I can't draw in there. Okay, but you've got this whole matrix type thing. So you've got a 2x2 matrix, you've got a 1x2 matrix, a 2x1, and then the 3x3. We'll get to the 3x3 here in a minute, but we only need a 2x2 for this one. So if I click on that, it puts in a 2x2 matrix inside my parentheses. Okay? And then, notice how the cursor is flashing in that first location. So if I hit 3, then -2, and I'm using tab to go between each of these, and then we get to 1. Okay? So I've typed in the determinant of the matrix that I'm looking for. Okay? And then when I hit enter, by gosh, by golly, by G, it's 15. Now, if I wanted to find the value of something larger than a 2x2 matrix, when I go into there, I pick this 3x3 matrix, okay, and that then lets me create a matrix. So I can create a matrix of any size, but since I'm doing determinant, that row number better be the same as the column number. Okay? And I could do, if I wanted to do a 10x10 matrix, I could do a 10x10 matrix. And it would be very easy to do. Okay? All right? Okay? Now, 3x3 matrices. Okay? Here we're getting a little more complicated, okay? But we can still find them by hand. Okay? So, if I am finding a 3x3 determinant by hand, the first thing that I have to do is I have to copy the first 2 columns. On the right of my matrix or my determinant, whichever one it is. In this case, we have it given to us in determinant form. Okay? So we're going to copy the first 2 columns on the right. write those down. Then, step number 2 says I am going to add the 3 Chris numbers. Okay. I get 3 Chris numbers this time. Here's 1. Oops, I went the wrong way. Here's 1. Here's 2. And here's 3. So that would be 4 times 1 times 3 plus -2 times -2 times 2 plus 0 times 1 times 5. Like the song goes, it's still even on it. Yep, it is. Oh, it's not. Okay. Now I'm going to subtract off the 3 cross numbers. Okay? So my cross numbers, 1, 2, 3. So that's -2 times 1 times 0 minus 5 times -2 times 4. Oops, now I don't want mixer. Okay, and then minus 3 times 1 times -2. Okay, so that gets me 12 plus 8 plus 0 minus 0 minus -40 minus -6. Okay. 12 plus 8 is 20. Minus -40 is 60. Minus -6 is 66. So the determinant here is equal to 66.
That's how you want to write it.
Determinant. And then if like in this particular case we didn't have the name of the matrix, but if there was a name then, like in the last one I think I said determinant of A. Or not the very first one. Determinant of A. Yep. Okay. Yep. Okay. So. Okay. Now, find the value of that. I'll rewrite that matrix up here, but I want you to find the value of this one using your calculator. If you can't read that, there they are. So, type in DET again. Oops, I missed the D. DET. Okay. And then open up a set of parentheses. Go in. This time I want it to be a 3 by 3 matrix. Okay? So then we type it in. 4, -2, 0, 1, 1, -2, 2, 5, 3. Should be 66.
Once I got that same answer.
That's good. Okay. Okay. Find me the value of that determinant. I get 453.
That's what I got once.
Okay? Now, my question to you is this. If we follow the same pattern that we did in 3x3 matrices, would we get the same answer if we had to do a 4x4 by hand? So, yeah, that's what I'm saying.
Yeah, you get the same answer.
Well, let's try it. Okay. So what did we do in a 3x3 by hand?
We wrote the first two rows on the
We wrote the first two.
columns.
We wrote the first two columns on the right side of it, right?
Yep.
Okay. So here I would have to write the
First three.
first 3 columns on the right. Okay. So then I would have what, Carson? I'd have 4 Chris's, right? Okay. So my Chris's, 7, 3, 0, -7. What's that one? 0, right? Okay. 2, -5, 0, and 1. 0. 1, 2, 1, and 4. 8. 6, -4, 8, and 7. You guys all have calculators in your hands? 6, -4, 8, and 7. $1,000, what did you say? 344? Okay. Then what?
Then you gotta cross it.
Now I gotta cross it now, right? So I gotta subtract off these. 5, or excuse me, 6, -5, 8, and 1.
-240.
-240. 4, 0, 2, and 7. 7, 0, -4, and 2. -7, 1, 3, and 1. Is that 453?
Sure. Yeah.
Nowhere near it, is it? What is it? What do we get? So can we do that? No, can't do that. Okay? So how you actually do it,
There is a way to do it.
there is a way to do it. Okay? How you actually go about doing it is you pick any row, and that's your row. Okay, you know what I mean? You pick any row. Okay, so I'm going to pick the first row. Okay? So I would take 7 times that. Okay? With me? Then I'm going to subtract off 2 times that. Well, you pick any row. It'll work with any row. And then you find the value of the remaining 3 by 3.
This one would be easiest to do. Yeah, the zeros in it.
Okay. Then you add to that one, and then you subtract from that one. Okay. So it gets a little more complicated as you go along. Okay? But that's why, luckily for you, you have a teacher that won't go anything bigger than a 3 by 3. Okay? Unless you're using a calculator. Now, I will say, however, that you don't just rely on the calculator. Okay? Because there will be questions on the test specifically saying solve or find the value of this determinant by hand. Okay? Or solve this one using Kramer's rule by hand. Okay? So don't rely solely on the calculator. Know the steps on how to do it by hand. Okay? So Kramer's rule is here. Okay? Now, on paper, Kramer's rule is like this. Okay? On paper. But when you get to be using Kramer's rule, it actually is not that. Okay? So, Kramer's rule uses determinants. It's the fourth way to solve a system of equations. And it will work with a 2 by 2 system. It will work with a 3 by 3 system. It will work with a 4 by 4 system. Kramer's rule works for any size of system. Okay? When you see Kramer's rule, okay, I go about things a little differently than most. Okay? Just because of the way things fall and how I remember it from back when I was your age, walking to school uphill both ways through drifts of snow 17 feet high. Okay? So the very first thing that I do with Kramer's rule is I find these two determinants first. Okay? And the reason that I find those two first is because these are the coefficients. Oops, I spelled that wrong. Of x and y. Actually, I forgot one thing before that. Okay, make sure you line up your equations first. X's, Y's, numbers. Okay, get them all lined up in order. X's, Y's equals numbers. Okay. Then those down here are just A, B, C, and D. A, B, C, D. Okay. So we find those straight off of the coefficients of X and Y. Okay. Then, to replace, or to find the X value, I replace the X coefficients with the numbers. I haven't used the numbers E and F yet, so I replace the two X coefficients. The two X coefficients were A and C, and I replace them right there with E and F. Because if I didn't replace them, X would always be equal to 1, because I'd be dividing the same thing by itself every time. Okay? And we've known for years, X is not always 1. Okay. Then, to find Y, I replace the Y coefficients with the numbers. Okay? So B and D were the Y coefficients. They got replaced with E and F. I've already found this determinant down here because it's the same as the X. Okay? Let's put it to work. We'll do one example where we use Cramer's rule first. Okay? So, my first check says that I need to make sure that everything's lined up. X's, Y's, equals, numbers, all lined up. Okay? So, then, to find X, the first thing that I do is I find the coefficients, 3, -1, 2, and 5, in that order down there. On top, above that, in the numerator, I'm going to take the 3 and the 2, and I'm going to replace it with -8 and 6, leaving the -1 and 5 where it's at.
Why did you do that one?
Because that's what Cramer's rule says to do. Okay? So now this becomes -40 minus -6 over 15 minus -2. -40 minus -6 is -34. 15 minus -2 is 17. -34 divided by 17 is -2. I already know that the denominator is 17. Because it's their same denominators as it was in the last one, and for x. So I've already calculated it once, no need to calculate it again. Okay? So I take that denominator matrix. Now instead of replacing the 3 and the 2 with the numbers, I'm going to replace the -1 with -8 and the 5 with 6.
Why are we using -8 and 6?
Because they're the numbers.
Oh, okay. I didn't know.
Okay? So then this becomes 18 minus -16. All of that is over 17. That gives me positive 34 over 17. So y then is equal to positive 2. Now, what should I do
Check it.
next? Check my work, correct? Okay. 3 times -2 is -6. Minus 2 is -8. So it works out in the first equation. 2 times -2 is -4. 5 times 2 is 10. -4 plus 10 is positive 6. So my answer here then is the point -2, comma 2.
So that's Kramer's rule. Now, how does can you use Kramer's rule with a triple variable?
3 by 3.